Assalamualaikum and hi everyone. My name is Dhiya Syariah binti Mazelam and I would like to presenting my final year project with the title Evaluation on Corrosion Behavior of SUS 304 stainless steel at different pH. Table of content. There are 5 chapters will be discussed in this video. First, introduction, literature review, methodology, result and discussion, and lastly, conclusion and recommendation. First, introduction. Study. Corrosion is known as the destructive and accidental corrosion of metals due to the electrochemical process induced by the environment. When one or more of the atoms on the same metal surface are oxidized, creating damage to the entire surface, this general corrosion happens. Any interaction between the element of canned food and the material of the can through a canned citrus juice conservation. The chemical structure of the products, the condition of the tin plate, and the presence of corrosion accelerators such as sulfides, sulfur dioxide, and oxygen also affect corrosion of canned acid products. Corrosion degradation, lack of seal integrity, or discoloration issues are significant issues due to the use of tin plate cans in corrosive food products. In addition, other research has suggested that the food safety problem was caused by elevated levels of tin in the food component. While its corrosion material do not contain harmful compounds or affect the taste, several digestive disturbances are made caused by very large doses. Problem statement. First, tin plate corrosion occurs on two sides, either inside food-contained cans, characterized by metal dissolution, which is an electrochemical reaction, or outside of cans due to metal and environmental conditions. Second is in a corrosion reaction, can change the organoleptic properties of food and can trigger contain toxicology problems in human health. Third is pH of food products, which have different pH based on their type of food products, which is that food already processed and packed inside a tin can contribute to corrosion inside the tin can. Next is significance of the study. First, the result will benefit some groups such as researchers, students, food industry players, and tin plate manufacturers. Second, the information will assist them to know the consequence of exposed tin plate into the different pH of solutions. Third is can facilitate industrial practitioners such as food can manufacture and food packaging teams to discover appropriate strategies to overcome tin plate corrosion problems. The objective is first to determine the corrosion rate of stainless steel coupons after immersed in a corrosive media at different pH. Second is to investigate the effect of corrosion on stainless steel coupon after immersed in the corrosive medium at a different pH. And lastly, to evaluate the corrosion behavior and the morphology of corroded stainless steel coupon surfaces through microscope analysis. Next chapter, literature review. Issues on contaminated food by tin. Tin toxicity refers to the toxic effect of tin and its products. Cases of tin metal toxicity, its oxide and salts are almost unknown. On the other hand, such organic compounds are almost toxic as cyanide. Tin plate. Tin plate is composed of sheets of steel covered with a thin film of tin, with the tin coating applied either by dipping in molten metal or by electrolytic deposition. Almost all tin plating is now created by the latter procedure. Tin plate made by this procedure is basically a sandwich in which the central core is a strip of steel. Tin is a chemical element with letters as end. Corrosion mechanism of tin plate. First, corrosion of tin plate in acidic. Studies have shown that artificial fruit juice with preservative are more corrosive than normal fruit juice and water because they have high acidity. Due to the reduction in the overall potential hydrogen, tin was found to corrode more readily in tartaric acid. The preservation was caused by tin hydroxide film or by oxide film. Is corrosion of tin plate in basic. The result shows that weight loss and corrosion rate decrease With rise of pH values from 7.2 to 11.2, this is indicate that the weight loss was directly proportional to corrosion rate. Corrosion often play in natural. Gelatin is completely immune to heat or cold distilled water. Of corrosion in food can. There are two types of corrosion in food can, which is internal and external corrosion. Internal corrosion in food can is an electrochemical reaction. It's a reaction occurs inside food can as internal corrosion, and its degree of corrosion depends largely on the acidity and condition of food. Of tin cans is dependent on the metal itself, the hydrogen overvoltage and surface homogeneity, the production of galvanic microcells in the metal heat treatment plant due to the non-homogeneity of the metal surface and the contact of one component with another. Alteration of pH during food storage. While tin has the tendency to develop soluble complex with certain anions, tin corrosion is accelerated if this occurs. The product can move into brine and cause corrosion by organic acids in it. To contribute acceleration of corrosion in the storage of food with pH below 7, very small number of nitrate, up to 0.01 gram, was added. Is corrosive media. Corrosive media is an element, solution or compound that is distributed as a corrosion testing environment. The reaction of different materials depends on the type of the media existing. Next is corrosion analysis. Corrosion rate. The rate of corrosion is the rate at which any metal deteriorates in a specific environment. Morphology study. Morphology is the shape and size of a line, region, or volume, the composition or topography of a surface, the behavior of a crystal, the arrangement of phase in a system. Shape may mean either of these or it may refer to a structure, but it does not have a clear definition until one is defined. And weight loss techniques. Total immersion testing for corrosion studies evaluates how well the metal holds when total immersed in water or other liquids. Immersion corrosion testing is used to assess the material's resistance to an aggressive aqueous environment. Next chapter is methodology. Preparation. The stainless steel coupon SUS 304 stainless steel was provided with an average size 20 mm times by 20 mm and thickness of 1 mm. Stainless steel coupon samples were polished and treated by abrasion through successive grades of abrasive paper to clean and remove any outside layer on the sample surface by using polishing machines. Then the samples were subjected to a cleaning process with ethyl alcohol to remove dirt and any grease of oil and then dried up. Then the initial weight was recorded for each sample. Next is preparation of corrosive media. This research was conducted using different pH of corroding media, which are pH 2, 4, 2, 5, 7, and 9. Corroding media with pH 2 and pH 9 were prepared respectively by adjusting the pH of the acidic solution used in this study, 0.1 mole HCl solutions. For pH 7, pure water was used in this experiment to evaluate the corrosion rate. For pH 9 was prepared by adjusting the pH of the alkali solution used in this study, which is 0.1 mole NaOH solutions. To obtain different pH of corrosive media, pH meter was used to make sure desired pH value were accurate. Test. For total immersion test, 250 milliliter different pH of corroding media were filled in the 500 milliliter beakers. All the samples were immersed in the corroding media in each beaker. The samples exposed to corroding media throughout different immersion times 2, 4, 6, and 8 days at room temperature 25 degrees Celsius in the fume hood. At the end of each test cycle, samples were washed with tap water, distilled water, and the ethanol from the corrosion media. After that, the samples were weighed using weighing scale to measure the weight loss. Weight losses obtained after immersion complete for each week. To obtain weight loss value, the difference of initial weight and final weight were calculated. Next is the surface morphology of the specimen should be performed by using an optical microscope. Prior to and after removal of the corrosion product to be observed, the cause on stainless steel coupon attack by corrosion media. And lastly, the corrosion rate was calculated using equation and the obtained result was analyzed. Next chapter is results and discussion. Sample weight versus immersion times. The thin substrate showed a notable weight reduction after initial immersions in each pH value for up to 4 days. At pH 7, the weight loss slowly decreased compared to others due to the pure water that without dissolved gases such as oxygen, carbon dioxide and sulfur dioxide does not cause undue corrosion attack on stainless steel compound and most metal. The presence of chloride ions in corrosion medium might explain the behavior. The corrosion process in different pH values of HCl solution, which are pH 2 and pH 5, may be attributed to the presence of dissolved oxygens according to the results data. The amount of weight in pH 9 NaOH solution increases more compared to weight loss weight in pH 2, pH 5, and pH 7. This is due to the high pH of the sodium hydroxide solution, which increases the amount of hydroxy ions OH, which may have absorbed to the specimen surface. Results. Based on data obtained, stainless steel coupon exposure to pH 2 and pH 5 had similar results. Stainless steel coupon corrosion in corroding medium with a pH of 9 and NaOH solutions depends on the quantity of oxygen dissolved in the media and the concentration of the media. The more film builds up and the shorter the corrosion rate, the higher the concentration, which is the high pH value of an NaOH solution. Obtained for corrosion rate versus immersion time, the results show that when stainless steel coupon was immersed in different pH of corrosive media, for the first 4 days corrosion rates increased, but the corrosion rate decreased after 4 days. The figure shows the represents of morphology surface of stainless steel before and after immersion in HCl for 8 days. A coupon before immersion shows a smooth surface without any major degradation. In figure A, only a little scratch observed on the surface which was affected during coupon preparation process. No corrosion sign was detected on the coupon surface. The photos were created using a 10-time magnification optical microscope. Was immersed for 8 days. There is sign observed on the surface. Figure B indicating high corrosion rates. Through the image, it can be the appearance of pitting corrosion instead of uniform corrosions after the stainless steel coupon was immersed for 8 days. Last chapter, which is conclusion and recommendations. Conclusions and recommendations. When the immersion times were increased, the weight of steel samples decreased continuously. The corrosion behavior of stainless steel coupon is influenced by the concentration of chloride ion Cl- in the corrosion media. pH 9 NaOH solution increases more due to the high pH of sodium hydroxide solutions, which increases the supply of hydroxy ions. The results showed that as the amount of time spent immersed increased, the rate of corrosion reduced. The surface morphology revealed there is a sign, which is pits or cavities, observed on the surface after the stainless steel coupons was immersed for 8 days, indicating high corrosion rates. And this is the references that I use in this video. That's all from me. Thank you.